Experiments are probably the best part of science. I mean, really, what's not to love about a great investigation? But the part that bums a lot of people out is the scientific language. Terms like independent, dependent variable, constants, controls, multiple trials. I mean, really, why can't we just be curious and have fun? Well, we can, and we should. But you can count the key terms you need to know on just one hand. And most of the ideas are actually kind of common sense. Understanding these ideas will allow you to gather data with confidence and precision. Give me just a couple minutes and I'm going to make you a pro at the controlled experiment. So let's just say I'm having some fun combining green colored vinegar with some baking soda. I'm watching the gooey green amazingness and a question comes to my mind. Could I make this chemical reaction even better? Even more spectacular? Well, it sounds like I'm about to conduct an experiment. So this brings us to our first two terms, independent and dependent variables. Now, the word variable just means anything that can change or be changed in this experiment. It comes from the Latin word variare, which means to change. So what are some things that could change in this experiment? Well, we could change the shape of the container, the size of the container, we could change the type of vinegar, we could change the brand of baking soda. Of course, we could change the amount of baking soda or the amount of vinegar. And there's a whole bunch of other things that can change in this experiment too, like how high the chemical reaction goes in the tube, the temperature of the chemical reaction. There are a whole number of things that can change in this experiment, and these are the variables. Now, the independent variable is the variable that I, the experimenter, choose to change. Kind of easy to remember because independent starts with an I. In my experiment, I decided I am going to change the type of vinegar. I've always been curious if this apple cider vinegar will work as good as the standard white vinegar. Now, how am I going to know which type of vinegar works the best? Well, sounds like I'm going to have to take a measurement. And guess what? That thing that I measure is the dependent variable because it depends on what I changed. In this case, I'll be measuring how high the bubbles go inside the graduated cylinder. Now for our third term, constants. Constants are the things you keep the same in the experiment. Think about it this way. We want to devise or set up a fair test. The only thing that we're testing is the type of vinegar. So everything else we want to keep constant. We'll use the same container. We'll use the same amount of vinegar. We'll use the same amount of baking soda and the same type of baking soda. The only one thing we'll change is the independent variable. Everything else will stay constant. Now, you may be thinking to yourself, you know what? I just want to go all mad scientist on this thing. You know, I'm going to change a little of this. I'm going to change a little of that. I'm going to add a little more of this. I want to make an epic chemical reaction. And maybe you do. But then somebody asks you, why was it such a great chemical reaction? And you realize, if you change more than one thing, you don't know what caused the outcome. And that's why you only have one independent variable. It's time to run the experiment. But before I try my apple cider vinegar, I'm going to run a version of the experiment with the plain old white vinegar. This is going to be my control group. A control group is like a normal version of the experiment that doesn't get the change in the independent variable. We need this so we can have a basis for comparison to see if the apple cider vinegar really makes a difference. Now that we've got a measurement with our control group, it's time to go ahead and run the test with the apple cider vinegar. Wow, that was pretty cool. Apple cider vinegar for the win. This brings me, though, to our fifth and final term, multiple trials. What does that mean? Well, it means you should do an experiment more than once. It makes it more likely you'll come up with the right conclusion. Let's go ahead and run this one again, just to see. Now that was fascinating. When I ran the experiment a second time, the results flipped. The white vinegar outperformed the apple cider vinegar. That is why multiple trials are so important. What would I need to do to prove that one of these is actually better than the other? Well, I'd have to do a lot more trials to really come to a solid conclusion. Right now, I'm thinking maybe they're about the same. So now you know what the 5 key parts of a controlled experiment are. The independent variable, the dependent variable, constants, the control group, and multiple trials. I'm going to set up another experiment and let you practice by identifying those 5 components of the controlled experiment. So here's my experimental setup. I've got 2 English ivy plants that I bought from the same store. They're about the same size, they're in the same type of container with the same type of soil. I want to experiment and see if Miracle Grow Pour-In Feed will make an English ivy plant grow taller. What I will do is every day I'll give both of these plants 50 milliliters of water. However, only one of them will get an additional tablespoon of my Miracle Grow added to it. At the end of 10 days, I'll measure the length of these 2 English ivy plants and see which one has grown longer. Well, it looks like you're a pro at controlled experiments. Get out there, give it a try, and as always, stay curious, my friends.